These are the notes that are a continuation of the Chapter 15 notes that were started in class. So the first thing with this question, police report that 78% of drivers stopped on suspicion of drunk driving are given a breath test, 36% a blood test, and 22% both tests. First thing I need you to do is draw a picture. So in class we talked about a Venn diagram. So on this Venn diagram, we'll draw a box around the outside to represent the whole sample space. And it said that 78% were given a breath test. So mark breath here. And 36% are given a blood test. Make sure you're writing this in your notes so that when I move to the next slide and see the questions, you can answer those questions. And 22% were given both of those tests. Now, I don't know if I made this clear in class, but being given the breathalyzer test, that 0.78 represents this entire circle. So this whole circle we can say is A, and this one is B. So if we just wanted to know what was in this space, we would subtract 0.22 from 0.78. So I don't know if I made that clear, so make sure that you understand that 0.78 is this whole piece. Okay? All right, so on to the questions. Okay, so police report that 78%, oh, that's the same question. So what is the probability that a randomly selected DWI suspect is given any test? So that is the probability that they, and I will just refer to them as A and B. So that they're given the breath test or they are given the blood test. So that is going to be equal to the probability of A plus the probability of B minus the intersection of both, because we don't want to include those both times. Okay. So this is 0.78. That's an 8.78. Probability of B is 0.36, and then we subtract the 0.14. So this answer, the probability of A or B, is 0.92. And where I got that was 0.78 plus 0.36 minus 0.14. Okay, a blood test or a breath test, but not both of those things. So looking back at the picture, what we want then is this section, plus this section, because we don't want both of them, okay? So 0.56 is this, and this part is 0.14. Okay, so to answer that question, 0.56 plus 0.14, which is 0.7. Okay. All right, so if we were to write that in notation, it really is the probability of A or B minus the probability of A and B. Okay, so we can take the 0.92 from the question above and subtract the intersection again and still get 0.7. I just want to give you a couple of different ways to be thinking about that. Okay, so neither test, probability of neither is 1 minus the probability that they were given either test, or one or both of them. So whenever you see a negative, that means it's a complement. So 1 minus given either test is the 0.92 that we already discovered. So 0.08 is the answer here. Okay. All right, the next topic has to do with conditional probability. So conditional probability is a probability that something has happened so that it affects the next one. We've talked a lot about independence. So this would be two events are dependent. So the effect of one, or one happening, affects the second one. So this notation with the line in it means that it's a conditional probability. So the probability of A happening given that B has happened is equal to the probability of both of them happening divided by the probability of B happening. So you will see this often when it comes to a table, and this comment down here is that you probably will not have to use this. There are some examples in the on your notes where you'll have to use this probability, so make sure you refer back to this slide. Make sure it's in your notes because you will refer back to this, but you'll see when we're working through the tables that you'll just be able to use common sense because it has to do with the marginal conditions that we talked about before. Okay, all right, so I'm going to refer back to this picture quite a bit. It looks just like you've seen before where we've got grades and what if their goals are grades or being popular or doing sports and boys and girls and how many people were interviewed. Okay. All right, so you might want to pause it and be able to write this down. Okay, so the probability that the person that we're picking randomly is a girl. If we look back on the slide, so I'm going to assume that you have it written down, there are 251 over 478. Actually, I'm going to go back to it. So 251 girls out of the total of 478. So this is really just the probability of how many people could be girls out of the total options that there are. Okay, so the probability that it's a girl and whose goal is popular is 91 over 478. And I think most of this is common sense by looking at the question, and we'll get down to more of these. Sports is 90 over 478. Now, what's the probability that someone that we've picked, their goal is sports, given that that person is a girl? Okay, so it ends up being 30 over 251. The probability that it's a girl, given that they are popular, that we've chosen a girl given that they are popular, is going to be 91 over 141. Okay. Now, if I could show you this with the previous formula and we would get the exact same answers. Okay, the next topic is independence. And this is very important, okay? The notes I'm giving you are important, but this in particular because you will be asked to prove that two events are independent or two events are not independent. So two events are independent if the probability of A happening is the same as the probability of A happening given that B is happening. The only way they're independent is if or that A and B are independent if the probability of A happening has nothing changes given that B has happened. Okay, so that's how you're going to prove. You're going to look at the probability of A happening, and then you're going to look at the condition. And if those are the same, then you can say that those two events are independent. And here are some examples of that. Okay, so yep, that's the same thing. So the idea is that if the probability of A occurring is equal to the probability of A occurring on the condition that B occurred, then it had no effect, then they are independent. Okay, so the questions, is preferring good grades independent of gender? Now you might want to respond from a gut level saying, yes it is or no it isn't, and remember that's not what this class is about. You need to be focused on statistically proving that this is true or not. Okay, so independent of gender, so we're going to be comparing grades and gender. Okay, so first of all with gender, if we just say we're going to look at the girls, that will tell us. So because we're given information, and we could pick boys as well, okay? So we want to look at the probability of getting good grades. Is that equal to the probability of getting good grades given that the person is a girl? Okay, so are these going to be exactly the same? Okay, well, the probability that someone we've selected is focused on grades is 247 over 478. Okay. The probability of looking at grades given that a person is a girl is 130 over 251. And if we look at these as far as a decimal goes, 247 divided by 478 is 0.52, and 130 divided by 251 is 0.52. So because these are equal, we can say that good grades is independent of gender. Okay, so choosing success in sports, is that independent of gender? Okay, so same question. So is the probability of sports equal to the probability of sports given that the person is a boy? And again, we could have picked girls. It doesn't matter. We're just looking because if it's independent on one, it's going to be independent on the other. So looking at the chart, the probability of sports is 90 over 478. And the probability of sports if you're a boy is 60 over 227. Okay, so 90 divided by 478 is 0.188. 60 divided by 227 is 0.26. So because those aren't equal, we say no, this is not. And yes, this one is. Okay. All right. So that's how you're deciding if it's gender or not. Okay. So now that we know what independence looks like, this is the general multiplication rule. Okay. It's really the same that we've done before. So the probability of A times the probability of B given that A has occurred. Okay. Or the probability of B times the probability of A given that B has occurred. So pay attention to this, and I will send you, you'll have the slides independent of this video so you can refer back to it. But make sure you are paying attention to the order that is written here, because if you are given the probability of A given that B has happened, then you want to make sure that you're multiplying by the probability of B. Okay, because you're saying that if they're independent events, then this becomes the probability of A. So the probability of A times the probability of B. So this is the probability of A times the probability of B given that A has occurred. So you need to ask these questions to make sure you are multiplying correctly. Okay. Okay, so we've talked a lot about disjoint and independent, so make sure that you understand the difference. If they're disjoint, they can't happen at all together, like the spade and a diamond. Can't pick both of those. Independent means that one does not change the other one, okay? And I keep saying I'm going to address that, and I will give you a handout sometime this coming week, okay? All right, so you may pause this video and start the questions that are on the notes that I gave you, and post if you have questions.